Perfect. All right, so Unit 2, Lesson 13 practice, or 3.9 practice. This is, once we're done with this, we'll put all of it together. I am going to start drawing here. It says that the polynomial function b of x equals x cubed minus 21x plus 20 has a known factor. So when it wants us to write this as the product of all the linear factors, what we do is we take this and we do our polynomial long division. So we will take and we will do that x minus 4, and then we will draw our nice long division and put our x cubed, and I'm going to move this down here so it's a little bit easier for me to write, x cubed minus 21x plus 20. And I'm obviously going to end up writing over number 2, so just stay with me here. And I'll erase it afterwards. I just want you to be able to see, and maybe I can actually go to a work page. Where was that work page that I downloaded? Blank book. Here we go. Sure, we'll use this one. And can I erase everything? Maybe not. So we'll work on the sample page. Perfect. Okay, so again, I've got that x minus 4, and then we're going to do the long division here of x cubed. Let me see if I can remember. Minus 21x minus 21x plus 20. So if you remember, the first thing that you're supposed to do in a situation like this is you need to take it and you need to see, okay, x goes into x cubed how many times? Well, actually, I lied. I forgot something. What I forgot to do was to go in and add this 0x squared. And if you remember, we want to put this as in standard form as best as we can. And so what we need is we need to put that 0x squared in there so that we can take that into account. Now we say, how many times does x go into x cubed? Well, x squared times. So we put an x squared over our x squared. And then we multiply, just like we would in the box method. So x times x squared is x cubed. And then x squared times negative 4 is negative 4x squared. And we subtract. But I'm going to put parentheses around this so we remember that that's our 0. X cubed minus x cubed is 0. And 0x squared minus a negative 4x squared is a positive 4x squared. And then we can bring down our 21x. And we do the same thing again. So we will say, how many times does x go into negative or a positive 4x squared? And so for this one, you're going to take and multiply. And so you'll say that's got to be a 4x. 4x times x is 4x squared. 4x times negative 4 is a negative 16x. And then you subtract again. So that gives me my 0. And then negative 21 minus a negative 16 is like adding there. So really we're going back up, and I believe that one is 5. So that is minus 5x. How many times does x go into 5x once we bring down our positive 20? How many times does x go into 5x? And that one, let's just set that over there. And that one is going to be a negative 5. So there's our negative 5x. And then negative times a negative, they're the same thing. They're both going to be 0 and cancel out. And that is our factor up there. Okay? So that's part of it. Now, at this point, you've got x minus 4. I think I can just move down somehow here. We're all learning. There we go. So I've got that x minus 4 as one of my factors, and then my other factor is x squared plus 4x minus 5. However, it wants the product of all the linear factors. So if I take this down more, are you going to let me take it down more? No? I don't know what that is. I don't know what that is. I don't know what I'm adding here. That's fine. Ah, now I can take this down more and find random things that are written here. Very cool. And then back here, I'm finding it out. Here we go. Let's get rid of this random stuff. Sorry if it's taken so long. We're all learning. Nobody has any questions yet. That's fine. So I'm going to keep writing here. So I know I've got x minus 4. That's a linear factor. And I'm actually going to do the box method to solve this one. This is a method that we learned on Thursday of last week. So first of all, we know this is x squared. What times what is x squared? That's easy, x and x. And then we know down here this is a negative 5. So what times what is negative 5, but then adds together to give me a positive 4. Well, that's a positive 5 here and a negative 1 here. So that's 5x, and that's negative 1x. And so you can see my positive 4, and you can see my negative 5. So the final factor here, the final answer for this one, is going to be x minus 4, and then x plus 5, x minus 1. So that is the product of all these linear factors that you need for question number 1. All right, I'm going to go back up to the main question here. Wrong one. Here we are. And so we've got our answer there. Let's restore the file. You should be following me. It's not following on mine. Here we go. There we are. Okay, so you got your answer there. Hopefully you paused it, you got it, you wrote it down. Again, x minus 4 times x plus 5 times x minus 1. So the answer for number 1 is that. For number 2, let the function p be defined by p of x equals blah, blah, blah. X plus 9 is a factor. To rewrite it as the product of two factors, long division was used, but an error was made. So the question is, what is the error? That's what we want to find out. What's the error here, right? It says, how can we tell by looking at the remainder that an error was made somewhere? Do you guys remember what a remainder is? And if you don't, a remainder is that number at the bottom, that 999. That is a remainder. So when we do polynomial long division and we know something is a factor, the remainder should be 0. I'm going to leave and come back so that I can write again. Sometimes it's funny that way. So again, how can we look at the remainder and know that an error was made? So if we have a known factor, the remainder should be 0. I hope that makes sense to you. All right, moving right along here. Number 3, for the polynomial with a known factor of x minus 5, select all the other linear factors. Okay, So we've got x to the fourth minus 2x cubed minus 21x squared plus 22x plus 40. And we know x minus 5 is a factor. What we need to do is we need to set this up and do long division here. So, or the box method, either one, it doesn't matter to me. So you know that this is x minus 5. And you know that we got this long x4, x to the fourth minus 2x cubed minus 21x. And I know I don't have to fill in any zeros because everything's good there. 22x and then plus 40 here. I'll just throw that down at the bottom. So when you do your long division, again, start off thinking x times what is x to the fourth, and that's an x cubed. So we'll throw an x cubed there. And that means we'll do an x to the fourth minus 5x cubed. And we do subtraction, right? That seems like it's going to take me a long time to complete. So here's what I'm going to show you. I'm going to show you a shortcut. So first off, so I don't forget it because I'm prone to forgetting, I'm going to type this into our chat. All right, so I won't forget this. And here's my shortcut. We want to find all the linear factors, right? I'm going to go to Desmos. And when Desmos pops up, what I'm going to do is I'm actually going to graph this function. So I'm going to take x to the power of 4. Let's see, where can I get my power button? I can probably just hit that, go over. Oh, you know what? I'm so silly. I've got a keyboard. This should be easy. So x to the power of 4 minus 2x cubed minus 21x squared plus 22x plus 40. Everywhere that I see a function, that tells me what my linear factors would be. I know by graphing this that I will have a linear factor here at that x minus 4, but it's not x minus 4, it's the opposite. So it's got to end up being the parenthesis x plus 4. Do you see how x plus 4 crosses at that point, right? Also, x plus 1. Again, it crosses at that point. So there's 2 of them. The other one that I know I would have would be x minus 2. Again, it crosses at that point. You can see they're crossing the x-axis at the same spot. And then the one that they gave me here, x minus 5. Now, if I put all of those together, I should have the exact same graph as before. And by getting rid of these, you cannot tell any difference. If I get rid of blue, it's there. If I get rid of red, it's there. It's the same graph. So those are all of my linear factors. Now, that's pretty easy, right? So if I just took that and graphed it and saw where it crosses the x-axis, I would be able to find all the factors, just like we've learned in the past. So that's a quick shortcut instead of doing that long division, okay? Now let me go back here. So that means that, let's see, from my graph, we knew that x minus 5 was 1. We knew x plus 4 was 1. X plus 1 was 1. And x minus 2 was 1. So those are your 3. All right, if I move down, match the polynomial function with its constant term. So really all you need to do here is multiply all of the last numbers in each linear factor to see which one it's going to be. So for A, if you took and multiplied -2 times -3 times 7, that will tell you which one of those is going to be your factor. So that would be 6 times 7, which is 42. So A matches with 4. And again, that's the shortcut. Multiply the last term in each linear function. Look at that. Pop music superstar shocks the American Music Awards with a beat-up, bandaged face. Thank you for sending me that notification in the middle of class, Fox News. Moving on. I think you can do the rest of those. No problem multiplying the last one. I'll do one more with you. I'll do B. And B is 2 times -3 times 7. So that's -6 times 7. So a -42. So B goes to 2. Simple enough. And you can keep doing all of that until you get all your answers there. What are the solutions to the equation x minus 2 times x minus 4? Two ways to do it. You can graph, see where they cross at 8. So I could go back to my Desmos. Let me get rid of those. And I could take this x minus 2, x minus 4, and then I'll put y equals 8 here. And I'll see where they both cross. And it crosses here at 8, 0, and 6, 8. So my solutions would be at 0 and 8. Right? That would be at 0 and 8. Another way, algebraically, you could have done, you could have just set each one of these factors equal to 8. And solve. Nope, nope, nope. You could not have done that. You would have to subtract that over. And then find out where they cross the x-axis. So box method, blah, blah, blah. You could have done all of that again. That's why I show you the other way. It's a lot quicker. Graphing Desmos makes your life easy. We're almost done here, so I guess I'll go ahead and just do the last two with you, because a lot of this is review stuff that you might have already forgotten. Number 6 says the graph of a polynomial function f is shown. Which statement is true about the end behavior? So first of all, we know it's an odd power because odd goes in opposite directions. And so if you're looking at this, and I'll highlight the parts that I'm talking about, those are the end behavior pieces. So if I'm looking here, this is the x-axis, right? X-axis. Oh, can't see that. So x-axis there, which means as x gets closer and closer towards negative infinity, the y value goes down and down, down towards negative infinity, right? So as x gets larger and larger in the positive or negative direction, f of x gets larger and larger in the positive direction. That is not true. We know that not to be true because of this part going down. Part B says as x gets larger and larger in the positive direction, f of x gets larger and larger in the positive. That's a check. As x gets larger and larger in the negative, f of x gets larger and larger in the negative. So yes, B satisfies that answer. That makes sense to us. C kind of is in the opposite, and then D, again, they're going in the same direction, so D can't be it. So the answer to that one would have been B. And then number 7, the last question on your practice here, says the polynomial function p of x equals b. It has a known factor of x plus 4. Rewrite it as linear factors. Draw a rough sketch. So this is good. We will do all of this together. So again, I'm going to do this so I don't forget. I'm going to do the long way because I'll do both. I'll do both. Minus 6x and then minus 8. And I know one of my factors is x plus 4. Because I go away from this page and my brain turns into mush. So here it is. No, let's not do that. I want to just, how can I like clear all of this? I guess it doesn't matter. I'm going to click here and just scroll down. Now it no longer existed. Look at that. Boom. Well, yes, the back arrow would do some of that like that, but it just goes back and gets rid of everything. But I'd have to click it like 100 times. I'm not doing that. That's redonkulous. All right, so polynomial long division. We know x plus 4 is one of our factors. And we also know that it is x cubed, the polynomial, plus 3x squared minus 6x, and then minus 8. And if I'm looking at that, I have every x term between x cubed and nothing, so I don't have to fill in any 0 x's. Again, ask yourself to begin with, right? What multiplies to give me x cubed? That'd be x squared. So that's x cubed. X squared times x is x cubed. X squared times 4 is 4x squared. And we subtract. That will give us 0 here, which we want. And then we will bring down that negative 6x after we say what's 3 minus 4, and that's a negative x squared. Now we say what multiplies x to get a negative x squared, and that's a negative x. X times negative x is negative x squared. X times negative x times 4 is a negative 4x. So then here, subtract parentheses 0, and I will move down just a touch, go back and say what times x is negative 4x? That'd be negative 4. This right here, excuse me, nope, that's not right. Let me go back for just a second. I got a step ahead of myself. There's where the back button comes into play, right? Go away, go away. There we go. So I still got to do my subtraction. So negative 6 minus negative 4 is a negative 2x, and then bring down my negative 8. Now I need to think what times x is negative 2x. And so that's just a negative 2. So then that gives me, if I continued here, negative 2x, and then negative 2 times 4 is negative 8. So if I was to subtract that, which I need to, I should have a remainder of 0, and I do. The problem is I'm not done. And what I mean by I'm not done is I have a factor, x squared minus x minus 2 and x minus 4, but I need to factor that x squared minus x minus 2. So I'm going to do the box method. And I'm going to get x squared and a minus 2. I'm going to write it back up here so we don't forget. So that when we do the box method in reverse, that's got to be x, that's got to be x. What times what is a negative 2, but adds to give me a negative 1. There's only one possible way to get that because 2 only has one factor or one pair of factors. And so that's negative 2x, and that's just x. So my factors are as follows: x minus 4, x plus 1, and x minus 2. Could you have graphed that and found them a lot quicker? Yes, but inactive parts of tests if we ever get to that point. So you got to be able to do this in reverse as well. So we've got this. Now it wants us to actually graph it as well. So I'm going to graph it. I'm going to draw my graph here. All right, so my x and y axis are there. And what we know is that it does have factors here where it crosses at 4. So 1, 2, 3, 4. So I put a little point there. It has one at a positive 2. So I'll put that there. And if you know, this is where I'm getting my answers. And then over here at negative 1. So I'll put 1 there. We know it's a cubic because of the original function. So I don't need to worry about I need to worry about the end behavior. End behavior tells me that it's going to go. Let me see if I got a marker here. That's great. We'll see how this looks. So it goes down, looks like crayon, goes up, opposite directions because it's x cubed, and each one is linear. So it's going to go up and through each of those points of intersection. So that's going to be a rough sketch of that graph. So now you have all of 3.9 practice part 2 done. You should have all of 3.9 practice part 1 done. Copy it, submit it, and then you can work on your other assignments. You can do the optional assignment or whatever. Let me stop my recording here.